Welcome to this third session where we're going to do aromatic compounds, and our focus will be tutorial sheet for the April tutorial sheet 2026 CHE 2105. Okay, so question 16 was label each of the following aromatic rings as activated or deactivated based on the substituent attached, and state whether the group is Ortho-Para or meta-director. So one thing I want us to understand about Ortho-Para director is that when you're talking about Ortho-Para and meta-directors, one thing we need to understand is that for Ortho-Para directors, these are actually activating groups or activating directors. So what I simply mean by activators or activating directors is that they add electrons to the ring. So they add electrons to the ring. Then when you're talking about meta directors, so for meta directors, these are also known as deactivators or deactivating groups or deactivating directors. So for these meta directors, they are those groups which are able to withdraw electrons from the ring. So meta directors, we are saying that they actually withdraw electrons from the ring. So with that understanding, now let's look at these questions. Okay, so let's start with the first one. So the first one, you can see that we have a phenyl group attached to oxygen with a methyl. This oxygen direct attached. When you're considering the Ortho-Para or meta directors, you just consider the direct carbon, or the group rather, or the element which is direct attached to the ring. That is what you need to consider. So for this oxygen, we can see that this oxygen has some lone pairs of electrons. Because it has some lone pairs of electrons, meaning that it can add electrons to this ring. And because it can add electrons to this ring, which is the phenyl or benzene ring, when adding, it is able to activate the ring. Because it is activating the ring, therefore it is Ortho-Para. So for the first one, we're going to say Ortho-Para, and it is activating. Okay, Ortho-Para activating. Let's look at the second one. The second one we have, okay, it is this one, which is B. So for this second one, we can see that the element direct attached to this phenyl or benzene ring, it is carbon. And from what we can see here, carbon has reached its hybridization state, which is 4 things. It is attached already to 4 things. So there is no more room for this carbon to attach to another thing. So in this scenario, this carbon, because it has no lone pairs of electrons, it is able to withdraw electrons from this ring. Because it is withdrawing electrons from this ring, it is actually deactivating the ring. And deactivators are meta directors. So this one, we are going to call it a meta director, and we are going to say it deactivate the ring. Meta and deactivating. Okay, so deactivate. Okay, then let's look at C. So C is similar to the first one, which was A. This oxygen there, it has lone pairs of electrons, so it can donate electrons to this phenyl or benzene ring, therefore activating the benzene ring. So it is actually ortho-para. Okay, so it is ortho-para, ortho, it is ortho-para activator. So I'll just put in brackets activator. Now let's look at D. This D, there is nitrogen here. This nitrogen has also some lone pairs of electrons there. Because it has lone pairs of electrons, it can add electrons to this ring. Because it can add electrons to this ring, it is therefore activating this ring. Because it's activating this ring, it is therefore ortho-para. So this one is also ortho-para. And it is activating, because in the question we are asked to state if it is an activator or deactivator. Then we have this chloride attached to the phenyl group, but there is something special about halogens. So for halogens, of course, they have lone pairs of electrons which they can add to the ring, but these ones are very special. Instead of them activating the ring because of these lone pairs of electrons, they simply deactivate the ring, but they are ortho-para. So we are going to say this is ortho-para, ortho-para. But one distinguishing feature about halogens is that the halogens are able to deactivate the ring. They don't activate but they withdraw electrons from the ring, hence deactivating it. So we're going to say deactivating. Ortho-para, deactivating. Then let's look at the last one, which was a phenyl attached to sulfur, then attached to those oxygen and an alcohol there. So you can see that sulfur has to have about 6 electrons. Sulfur needs, or should I say, sulfur is just below oxygen, so it has 6 electrons in its outermost shell, meaning that it is able to form bonds, or it is able to form about six sigma bonds. Okay, so if we can count from this structure, we can see that we have 1 2 3 4 5 6. We can see that sulfur has formed 6 sigma bond, and we have 2 pi bond there. Okay, so we're counting just sigma bond. As the pi bond, we are counting just the sigma bond, 2 sigma bonds involved, because we have 2 double bonds there, meaning that it has 6. If you consider sigma bonds, it has 6 sigma bonds. Okay, so it has 1 2 3 4 5 6. So this sulfur does not have any lone pair of electrons. In this state, it has already been bonded to 6 different things, and all the electrons have already been depleted. So in this case, this sulfur, instead of it donating, it will be withdrawing electrons from this ring, the benzene ring, and because it is withdrawing, it will be a meta, and it will be deactivating the ring. So it is a meta and a deactivator. So these are the solutions for question 16 on the aromatic compounds, Ortho-Para and meta directors. Thank you for watching.